Today for vectors, I am going to deal with two planes. So right here I have my equation for plane 1 and plane 2, and I'm going to show whether the planes are parallel, perpendicular or intersecting. So to do that, we're going to write down the equation for plane 1 first. So for plane 1, I have my equation to be 2, 4 minus 1. This is equal to 8. Okay, this is equal to 8, and for my plane 2, I have my equation to be 1, 0, 3 equal to 6. Okay, so you can see here that I have my normal vector for my plane 1 and plane 2. So if you're gonna write it down, so you have for my plane P1, I have 2, 4 minus 1, and for my plane P2, I have my 1, 0 and 3. So if you look at this plane 1 and plane 2, the normal vectors for each of them, you can see that both of them are not equal. There's no, you cannot factorize out any common scalar multiple to show that they have a common vector. So since np1 is not equal to the scalar multiple of np2, so this shows you that the plane are not parallel. They are not parallel. Okay, so this is how you're going to show that they are not parallel. Then what about perpendicular? How are you going to show that they are perpendicular? So we're going to use the normal vector for np1 and np2. We're going to scalar product them. We're going to scalar multiply them. So we have my np1 and my np2. So if you're going to do scalar multiple, okay, so you're going to do scalar multiple, this is what you're going to get. You're going to get -1, and this is not equal to 0. And if it's not a value that is equal to 0, this means that the two planes are not perpendicular. It means that they are intersecting. So they are not perpendicular. So they are not perpendicular, but they are intersecting. But they are intersecting. Okay, so this is how you're going to show how the two planes are parallel, whether the two planes are parallel, perpendicular, or intersecting. So now we want to find the vector equation of the line of intersection when the planes are not parallel. To do that, we first have to write down the equation for plane 1 and plane 2 in the Cartesian form. So I'm going to write down for plane 1 and plane 2 in the Cartesian form. So for plane 1, we have 2x plus 4y minus z equal to 8. Okay, and we have our plane 2 to be x plus 3z equal to 6. Okay, so we are going to let z be the subject in this case. So we're going to form z equal to something. Okay, so you can see from plane 2, I'm going to make my z the subject, and from plane 2, we'll get z is actually 6 minus x over 3. And once you're done with that, remember to make x at the front, so we will have x minus 6 over -3. Okay, we're going to make x positive. My z is positive, my x is positive, so must my y be positive as well. So we're gonna combine plane 1 and plane 2 together to remove my x now, so that we can make y and z in the equation. Since this is an intersection question, we are allowed to do that. Okay, so how am I going to do that? First, we can multiply plane 2 by 2 throughout. So we're going to make 2x. Okay, we're going to use the elimination method. So I'm going to write here. So we have 2x plus 6z equal to 12. And these we're gonna subtract with plane 1. Okay, it's gonna be plane 1, so subtracting with my plane 2. Or my plane 2 subtract with plane 1, in this case it doesn't really matter as long as you can get z and y in the equation. So again, if you're gonna solve this, you'll get, so you're gonna minus them together. Let's say I get this be my 1 and this is my 2. So I'm gonna use my plane 1 in this case minus my plane my plane 2 minus my plane 1. So my plane 2 minus my plane 1. So this will get you 4y minus 7z, okay? Not z. It's going to be 7z equal to minus 4. And I have my y minus 1.75z equal to negative 1. I'm going to make my z the subject, and you're going to get this. Okay, once we're done with that, we can then combine them together. So you have something like this: x minus 6 over negative 3 equal to y plus 1 over 1.75 and equal to my z. And this is the Cartesian form for the equation of the line of intersection between the two planes. So you're going to write down the equation because they want the vector equation instead. So we're going to write this down. So we have 6 minus 1 and 0. Okay, and we have our denominator minus 3, 1.75, z is over 1, so it's 1 down there. And there you go, you have your vector equation for the line of intersection between the two planes. For the last question, we are asked to find the acute angle between the two planes. So I have written down here the formula that we are going to use to find the acute angle. And that's my theta there, cosine theta. So we're going to put down the normal for plane 1 and plane 2. So I have my cosine theta. I'm going to put it down. So this is 2, 4 minus 1 and 1, 0, 3. Okay, so this will be my 2 square, 4 square, plus minus 1 square. And this is going to be my 1 square plus 3 square. Okay, so once you have this, all you need to do is to solve it, cosine inverse it, and you can find your acute angle. It will be 86.0 in this case.